out, and you're going to have a similar one on your assignment, was a question where they say you have a number and it decreases by 20% of itself. This is the kind of a weird thing because it says of itself. You have a number decreased by 20% of itself, and then the result is 40. Find the number. So I highlighted that word of itself, those words of itself, because that's what makes this question kind of weird. So it says you have a number. We don't know what that number is, obviously. So maybe you want to put x, like a variable for that. You have a number. What is that number like? I don't know. So how about x? A number x. We don't know what that number is. So I'd start off with saying I have x, and then what should I put for decrease? When something decreases, like what kind of math symbol do I need? Yeah, subtract. So we just have to, it's just the weird part is it's decreased by, this is the weird part, 20% of itself. Okay, 20%, do you know how to write 20% as a decimal? Yeah, like 0.20. So we're going to decrease it by 20%. Okay, what do you think you do for when it says of itself, though? Yeah, you have to put an x again, like 20% times whatever that number was. So it's weird, yeah, it's like 0.20. The of itself is like another x. Use the variable again, the x again, because it said that number decreased by 20% of itself, so 20% of that x. And then the result is 40. So this first x you wrote down, isn't that 1x? So you need to combine these x's. What's 1x minus 0.20x? Yeah, if you just take 1 minus 0.20, yeah, it's 80%. It's like 0.80x equals 40. Or 0.8 is okay. You don't need to, I put 0.80, but then you divide by 0.80, and then you'll get the answer. See, it's just weird setting it up. That's why I wanted to go over that one, because it says of itself, so you need x, and then you need to put 0.20x. So 40 divided by 0.80, 50 is the answer. So it's saying you started off with a number like 50, and then you decrease it by 20% of itself. Yeah, 20% of 50 is like 10, and then you get 40. So that one's kind of weird. And lesson 1.3 is a bunch of little story problems. So we'll try another one, like something different. Another type of question might give you a price of a new car. So you have a new car, and it's worth $36,000. Okay, so when you buy a new car, yeah, it costs quite a bit if you buy a brand new one. But once you have that car for a while, the value of it starts going down. So they say it depreciates. Depreciate, that means it goes down. Depreciates by $4,000 per year. So they're going to ask you on your assignment to write a formula for the car's value. And you can use like a y variable, like y equals. So what could a formula be if it says you had a new car and then it depreciates by $4,000 every year? It's like they're asking you to try to write an equation that would stand for that situation. What do you think? Yeah, good job. So you start with the 36,000, yep. Yeah, and depreciate means something goes down. That's right. So it'd be minus. Good job. Depreciate's like minus. Good job. So minus 4,000 per year. So it's 4,000 every single year. It's going to go down by 4,000. So this is where you need a variable. Yeah, good job. So it'd be like 4,000x. Yep, like 4,000 times how x could be like however many years. Like if it's 2 years, you'd take 4,000 times 2 and then subtract. Okay, now writing a formula, that's not too bad. How about could you then use the formula? Like there'll be part B. Now use the formula you have to find the cars, when the car will be worth, to find when the car will be worth, let's say, 16,000. So we got a formula set up. That'll be like part A of the problem. We usually have like part A and part B on a lot of these. Use the formula to find when the car will be worth 16,000. So what do you think? Where should I put the 16,000? That's like the key. You put it where the y is, because that's like the car's value, the y. Yep. The x is like how many, like every year. The per year part is the x. See, like this per year part, that's like the x. And the car's value is the y. So now we want to know, when's the car's value going to be 16,000? Yep, so you put 16,000 for the y. Good job. 16,000 equals 36,000 minus 4,000x. Yeah, so it'll be like part A, set up the formula, then part B, use the formula to figure out things. So I'll have to subtract the 36,000. So that should be negative 20,000. Yep, that'll be a negative. Equals negative 4,000x. See, it's not too bad after that. Once you just like know where the number goes, then divide, and you should get it. So there'll be questions like that. 20,000 divided by, divide those negatives. 2 negatives make a positive, so it should come out positive. 5? Yeah, 5 years. So like after 5 years, your car's not worth as much. You've had it a while, you've driven it around, cars go down in value. They do go down pretty quickly, unfortunately. Except right now, cars are kind of hard to find cars, so I think there are some cars that they're selling pretty high. Yeah, they're selling pretty high right now, cars are. Okay, then, trying to go over each scenario, it's just like different story problems you come across. So let's just do one more of these kind, and then we'll get to those I problems, those complex ones. So let's do another one, like another little story problem. So this time, let's say they have college A and college B. They have like they're talking about different colleges. Okay, college A has 14,500 students. Okay, so right now college A, they're saying, has 14,500 students, and then they're projecting, that means they think this is what's going to happen in the future. They're projecting enrollment increase. They think the enrollment's going to go up. Of 1,000 students per year. Then we have college B. let's say that college has 40,000 students. A lot. 40,000 students. Some big, huge place. And they think that their enrollment's going to decline. So they're projecting that the enrollment is going to decline. Decrease, decline, however you want to say it. Decline by 7,000 per year, or 700 students per year. Students per year. Okay, so they give you like these two colleges, these two scenarios. So college A has a certain amount of students. They think their enrollment's going to increase. College B has 40,000. They think theirs, how many kids go there, is going to decline. So according to these projections, it says, it'll ask you when will the colleges have the same enrollment? When will these colleges, I'll just put colleges because I don't want to write a whole novel here. When will the colleges have the same enrollment? You know, I don't want to write a ton of stuff, but I wrote enough that I think you know the gist of the problem. So, two colleges. When will the colleges have the same enrollment? So, what do we have to do? What do you guys think? What does same mean to you? Same amounts, yep, same amount of students attending. So, we need to write an equation for this. What do you think the equation is going to be? Yeah, so if they have the same enrollment, yeah, you want to equal these things. Like we want to figure out college A and equal it to college B. When is it going to be the same? Good job. So you got the right idea. So 14,500 in college A, and they think their enrollment's going to increase. So it wouldn't increase be plus 1,000 x, 1,000 each year, like 1,000 x. That makes sense? And then, if she was right, you want to equal it. Equal it to the other college. The other college right now has 40,000 people, 40,000 students, but they think theirs is going to go down, decline. So you got to know, read it carefully when you read these. Increase is plus, declines minus, so 40,000 minus 700x. And you need the variable because it's 700 students per year it goes down, and 1,000 per year. The per year part is times however many years. You need a variable. So see, when it says same, so look for that when you do, if you have a story problem you come across, if it says same, it's things you want to equal. When it says same, you want to equal things. And you want to get your variables on the same side, I would probably plus this 700x, add the 700x, so I'd have 1,700x, and I would subtract the 14,500. Do those two steps to get variables to one side and the other numbers on the other side. So 40,000 minus 14,500. So here I got 25,500. Then you just have to divide by 1,700 and you'll get the answer. When will these two colleges have the same enrollment? So in 15 years, that's the thing. We got X is 15. So they'll have the same enrollment after 15 years go by. And we came across this the other day. If it asks you if they say, what year did this happen? maybe this is the scenario, maybe it started in the year 2000, so now it'd be like 2015. Sometimes you have to add the 15 years to the starting year, so watch for that. Sometimes you have to add your answer to the year it started in. But yeah, it'd be like in 15 years. So if they said this scenario started in the year 2000, then you'd have to add it. It'd be 2015, Okay, and then it's hard to go over every type of story problem you're going to encounter, but I'm trying to go over a few of them. There's a problem where they want you to just get the variable alone, like formulas. I know, like in science, you've dealt with formulas before. What if I gave you a formula and you have to solve a formula for a certain letter? Like, solve this formula for P. Because right now it says A equals P plus PRT. Solve for P. How do you solve for P? That means you have to get P, that letter P, alone. That's what you got to think about. When it says solve for that letter, you have to try to get that letter alone. Well, there's a letter P right there. There's another letter P right here. There's two letter P's. So what do? Some of you who've taken I don't know, it's like the people that know how to do this are the ones that are I don't know how to explain it. It's like you have to separate the P and get it alone. How do you get the P alone? Close. Anthony thought maybe divide by RT, but then you would divide this by RT, and then then that would have an RT under it, and then that P is not alone, it has an RT under it. And it's a good try, you're thinking about what to do, trying to get that moved. Can you get the P, separated from the RT, away from it? Well, that's times. So, you need to, what you have to do is to get P alone is you have to factor it out. Factor out the P letter. Separate it, put P parentheses, get the P out of this little addition thing. Try to separate it out. I know this is a tough one. That's why I put it on the notes. This one's hard to, you have to think of getting the P separated from the RT. If you divide by P, factor it out, it's like dividing this by P and dividing this by P. You would just get 1. P divided by P is 1 plus RT. See, now you have a single letter P that's separated from the rest of the problem. That one's a tough one. That's why I picked it. This one's a tough one that can come up sometimes. So that now that letter P is pulled out, separated from this. Now what Anthony said, he talked about dividing. Now you divide by 1 plus RT. You divide by that whole parenthesis thing. So you had the right idea. You were thinking about dividing. So A equals 1 plus RT. A divided by 1 plus RT equals P. That one's hard. That's why I picked it to go over. So if you see 2 of the same letter, you need to pull it out. If you see 2 of the same letter and you're trying to solve for that letter, you need to pull it out. That same problem could be totally different if I told you to solve for a different letter. I could start with that same problem again, and I could tell you to solve for R, and I would do it a different way. If I had the same problem again, I want to show you that, how the same problem can be done 2 different ways. What if I told you this time solve for R, the little R in the problem? Then it's different, I don't have to factor out the P this time. if they say solve for r, I would just minus this first letter p and bring it over here. See, it's different if it's not solving for the double letter. If it's not solving for that double letter, you can just subtract the first big letter p and bring it to the other side. Then you can divide by, you're solving for r, so you can divide by the other letters. Divide by p, t. See, it's totally different if it's just solving for a single letter. A minus p over pt. That'd be the answer if they wanted you to solve for r. So you gotta pay, you have to watch for that. I'm trying to show you that if you have a double, like two of the same letter, and it said solve for that letter that occurs twice, you need to factor it out. But if it said solve for r, there's only one r, so I'm good, so I can just minus and divide. See, it's different. It's like different scenarios. That's kind of weird. Okay, then finally, lesson 1.4. I think the lesson 1.4 is a little easier. The story problems seem to be harder because, you know, that's just the nature of story problems. They're just harder. You have to think them through. 1.4 will be a little easier. It deals with square roots of negative numbers, imaginary numbers, they call them complex numbers. Complex numbers are numbers like square root of negative 1, that's I, or square root of negative 9. So this part of the assignment shouldn't be too bad. The story problems will probably be the hardest. They'll have you simplify things like, could you figure out square root of negative 16 plus square root of negative 4? And something like simplify. Okay, so what's the square root of negative 16? Yeah, so it'd be like 4i. Square root of 16 is 4. Yep, and it has this negative, so that's the I, the letter I. That's the complex part of it. What's the square root of negative 4? 2i. So add that up. What do you get? There's your answer. See, that won't be too bad. Just gotta remember square roots of negatives. You have to put I. That's not real difficult. You're gonna have to do some addition or subtraction. Let's try one of those. Like, what if you had to do 5 minus 11i minus 3 plus 6i? Add and subtract, like terms. You add that up. Some of you notice, I think a lot of you remember, it has a negative in the middle, so you gotta remember that negative applies to things behind it, like distribute your negative. So what do you think? There's a plain number 5 over here and a plain number 3 over here. What do you get if you put those together? Yeah, it's minus in the middle, so it's like 5 minus 3. Yep, that's 2. Okay, so that's 2. Okay, now this one's negative 11i, and then it has this minus in the middle, and then over here is a 6i. See, you have to remember this minus goes with this 6 over here too. Like first I did 5 minus 3, I did that first, which was just came out to 2, we got that. Now I'm doing the I part, yeah. What'd you get? Yep, negative 17i. That's the answer. See, so you have to put like the real part of the problem together first. The 5 and the 3 are just real regular numbers. and then you have to do the imaginary part. The I part's the imaginary part. So they call this a complex number because it has a real part and an imaginary part. That's why they call it complex. It has real and imaginary in it. See, it's just like putting together like things. Yeah, like putting these I things together. You got that. Okay, let's try, what about if you had to do a multiplication one? What if you had to do 7 minus 3i times 2 minus 5i? What if you had to multiply? Do you remember how to do that? You have 4 steps to do here, you guys. First, you have to do 7 times this 2. That's 14. Yep. Then you have to do 7 times the way end, like way out here. Yep. Minus 35i. Then the inside, yep, minus 6i. Good job. Then the last one is this negative 3i times this negative 5i. Remember, a negative times a negative is positive. 15i squared. Now combine some things. That's not quite done yet. It's almost done. You could put the 35 and the 6 together, the 35i and the 6i. So we got 14 minus 41i. Okay, what does I squared equal? Probably have to put that like we said I. What's I squared? What does that equal? No, you guys are getting closer. Negative something. If you square this, what's written right here, if you square both sides, what do you get? You have a square root and you square it. You guys forgot, huh? You learned it in Algebra 1 or Algebra 2, but I squared is negative 1. If you took this and squared it, square a square root, the square root goes away, you get negative 1. So when you do this problem down here, you get an I squared. That's actually a negative 1. So it makes it 15 times negative 1. It makes it minus 15. So you multiply it all out, then you combine some things, and you have to remember I squared is actually negative 1. So almost done. You could put together this 14. What's 14 minus 15? Those can go together. See? 14 minus 15, that'd be negative 1 minus 41i. That'd be the answer. So multiplying's kind of tricky because you have to do FOIL. You have to remember about I squared. I squared is negative 1. I know for some of you it's been like 2 years since you took Algebra 2, so it's been a while. You forget. I know. You did that in Algebra 2, but it's been a while. Okay, last thing, what about a dividing problem?